Hello students, welcome to engineering assignments. In engineering assignments, we are going to deal with minimum spanning tree algorithms. So first one we are going to study is Prim's algorithm. For watching this Prim's algorithm video, you should watch minimum spanning tree video which I have put the link in description. Prim's algorithm is actually a greedy algorithm. It basically aims in finding out the minimum spanning tree. Minimum spanning tree for connected, weighted, undirected graph. Okay, so graph should be connected one and there should be the weight attached to each and every edge in the graph, and it should be undirected also. There should not be any direction from one vertices to another vertices. And it also finds the subset of edges that forms a tree. And you already know that minimum spanning tree will be having all the vertices which are there in the graph, but the edges will be one less than that of the number of vertices in the graph. Okay, so we call it as a subset of edges. Now we start from one vertex and we keep on adding the edges with the lowest weight until you reach a goal of getting a minimum spanning tree. Okay, next is a basic step for implementing Prim's algorithm. First thing is that you will have to initialize a minimum spanning tree with a vertex chosen at the random. So after initializing the spanning tree, you have to choose a starting vertex and you can choose any vertex as the starting vertex. Next, you have to find the all edges that connects the tree to a new vertices, and we will find out the minimum from that. And we will add it onto the tree. And you have to repeat this step 2 until we get a minimum spanning tree. Okay, so based on all these rules, we will do a problem.
So this is a graph which is given to you. First thing what you have to do is you have to remove the self loop. There is a self loop over here and it has to be removed. Never mind the weight and all, you will have to remove this self loop. Next thing, you will have to remove the parallel edge. So you have to remove the edge with the highest weight. You can see parallel edges there between B and D. Okay, you can see two edges are there. Among this, which one is having the highest weight?
The 8 is having the highest weight, so 8 has to be removed.
So you have to remove this. Okay, so you will have to remove this and you have to remove this and the graph will become as such. Now we are going to find out the minimum spanning tree for this graph. So you can choose any of the vertex as a starting vertex. Here I am going to take A as a starting node. If A is the starting node we have taken, you have to find out minimum outgoing edge from A. The outgoing edges of A has a weight 7 as well as a weight 8. So which one is minimum here? You can see this one is minimum. I'm going to take this edge. Okay, so I'm drawing above with a different line, but in the answer paper you have to draw as different diagram. Okay, now from A to B you have found out a minimum edge, that is the edge having the weight 7. Now you have to check which all are the outgoing edges now. So from A also you have to take, from B also you have to take. From A the outgoing edge is having a weight 8. From B you have two edges, one is B to D, one edge is there, that is 6. Then B to C edge is there, that is 3. So which one is the minimum out of this 3? This one is a minimum, so I'm going to take this. Now you have to find the outgoing edges from C, but not only C you have to find, you have to take care of the outgoing edge from B also, A also. So here you can see that the A is having an outgoing edge 8 here. Then from B it is 6. From C to D the edge weight is 4. From C to E the edge weight is 3. So you have to take this edge next. Now you have to take care of the outgoing edges of E. So outgoing edges of E is E to F it is 2, E to D it is 2. Also you have to take care of all the other edges, that is A to C it's 8, B to D is 6, C to D is 4. So which one will be the smallest? This one or this one? So you can take this one or this one. So for the time being, I'm going to take this edge. Alright. Now you have to take care of the edges which is going out of F. That is F to D. Okay, that is 5. As well as E to D, that is 2. C to D, that is 4. B to D, that is 6. A to C, that is 8. So which one is the smallest one? This one is the smallest one. So we'll take this. Now we will check whether we have included all the vertices. A is there, B is there, C is there, D is there, E is there, F is there.
So we have included all the vertices in this graph.
So this is the minimum spanning tree of our graph. Alright. Here total cost is 17. Next we have to check whether it qualifies a minimum spanning tree property.
Yes, it qualifies a minimum spanning tree property because there is no cycles in it. We haven't included any edge that makes a cycle in this tree. Next, here the graph has 6 vertices. So, number of edges will be 6 minus 1, that is 5. That is also qualified in this. So, this is a minimum spanning tree. Okay students, I hope it is clear for you. Thank you students. Thank you for watching my video.